Welcome back, everyone, to the deep dive. We're diving into a paper today all about large language models.
Those things behind tools like ChatGPT.
Right, and get this
Yeah.
paper, it found these tiny bits of text.
Oh, wow.
Yeah, and they're called critical tokens.
Oh,
And these critical tokens can totally change.
interesting.
Yeah. How well an LLM solves a problem.
Hmm.
Especially math problems.
Mhm.
It's like,
Yeah.
imagine one tiny little typo in your spreadsheet
Yeah.
messing up all your calculations.
Yeah.
That's kind of the impact we're talking about.
Wow. It's really remarkable.
Yeah.
The paper is called
Okay.
Critical Tokens Matter.
Oh, cool.
Token-level contrastive estimation enhances LLM's reasoning capability.
Okay.
And it really just dives into how these
Yeah.
seemingly insignificant tokens
Uh-huh.
can make the difference between a correct answer and a
Yeah.
totally wrong one.
So before we get too far,
Okay.
what exactly are these critical tokens?
Think of it this way.
Okay.
LLMs,
Yeah.
they break down language into these individual units called tokens.
Okay.
And these can be words, punctuation marks,
Right.
even spaces.
Okay.
And what the researchers found is
Yeah.
some of these tokens carry a lot more weight than others
Interesting.
when it comes to the LLM's reasoning process.
How did they figure that out?
Yeah.
It's not like you can just look at a word and be like, that's going to mess things up.
It's not that obvious.
Yeah.
They designed these experiments
Okay.
where they forced the LLM
Okay.
to solve the same problem
Okay.
multiple times,
Got it.
but they kept a specific token
Yeah.
constant each time.
Okay.
And what they found is that
Yeah.
if that token was critical,
Mm-hmm.
the LLM would fail almost every single time.
So it's like they were deliberately tripping up the LLM.
Exactly.
Hello.
To see which words were causing problems.
That's so cool.
And the results were really dramatic.
Wow.
In the paper, there's this graph, figure 1,
Okay.
that shows the difference in the LLM's accuracy
Mm-hmm.
when they kept the critical token
Yeah.
versus when they replaced it.
Wow.
The change is huge.
That's crazy. So we know that some tokens are way more important than others, but do we know why
Right.
these critical tokens have such a big impact?
That's the million-dollar question.
Yeah. What's actually going on inside the LLM that makes them so sensitive to
Wow.
these specific words?
The paper uses this great example
Okay.
to illustrate this.
Okay.
Let's say
Yeah.
you have a word problem
Uh-huh.
about how much money someone owed.
Okay.
The researchers found
Yeah.
that if the problem uses the word owed,
Mm-hmm.
the LLM often stumbles
Really?
and gives the wrong answer.
Ah.
But if you change that one word
Okay.
to paid,
Wow.
the LLM suddenly figures things out.
Wait, seriously?
That's what they found.
Just changing owed to paid makes that much of a difference.
It seems like that one word
Wow.
in that specific context
Yeah.
sends the LLM down the wrong path,
Crazy.
even if the rest of the problem is the same.
So it's not even about the math itself. It's about how the LLM is
Yeah.
understanding the words
Yeah.
and their relationships to each other.
Yeah.
It's like that one word throws off.
It highlights just
Yeah.
how sensitive
Yeah.
these models can be
Yeah.
to the nuances of language.
It's like it throws off its entire line of thinking.
You got it.
Wow.
And it raises all these interesting questions
Yeah.
about
Yeah.
how LLMs are actually representing these concepts
Yeah.
internally.
Mm-hmm.
There's this visual, figure 2, in the paper
Okay.
that shows all these different responses
Mm-hmm.
the LLM generates.
Yeah.
Some correct,
Yeah.
some incorrect,
Yeah.
just by changing that one word.
Wow.
It really drives home the point.
Okay, this is blowing my mind a little bit. Yeah.
You've got these critical tokens
Yeah.
that can make or break
Correct.
the LLM's reasoning.
Right.
But how do we even find them in the first place?
Yeah.
It's not like we can manually go through every word
Right.
in every single problem.
You're right. That wouldn't be practical at all.
No?
And that's where the researchers came up with this ingenious solution
Okay.
called contrastive estimation.
All right. Let's break that down.
Okay.
What exactly is contrastive estimation?
Yeah.
How does it help us find these sneaky little critical tokens?
Right.
Contrastive estimation sounds intriguing, but also kind of complex.
Yeah.
How does it actually work?
It's actually a pretty clever idea. Imagine you have two LLMs.
Okay.
One trained on a bunch of correctly solved problems.
Gotcha.
We can call that the positive model.
Okay.
And another trained on like incorrectly solved ones,
Yeah.
the negative model.
So we're training one LLM to get things right
Yeah.
and one to mess things up.
Yeah. This.
Yeah, so the researchers realized
Yeah.
that by comparing how these two models analyze each token,
Okay.
they could pinpoint the critical ones,
Oh.
the tokens that the negative model loves, but the positive model avoids.
Okay.
Those are our red flags.
Oh, that's cool. So they're looking for the tokens that are attractive to the LLM
Mm-hmm.
that's making all the mistakes.
Yeah.
And then you can use that to figure out, okay, this is where
Okay.
it's going wrong.
And the paper includes this helpful visual figure 3
Okay.
to illustrate this.
Okay.
It shows how the two models
Mm-hmm.
have completely different probability distributions
Wow.
when it comes to certain tokens.
Interesting.
It's a very visual way to see how they zero in on those critical tokens.
That's cool.
Yeah.
Okay, so this is all incredibly clever, but what can we actually do
Yeah.
with this knowledge?
Right.
Does it just help us understand LLMs better?
Uh-huh.
Or can we use it to actually like...
That's the great thing about this research.
Okay.
It's not just theoretical.
Okay.
They actually developed this new training technique
Oh, cool.
based on this concept of critical tokens
Okay.
called CDPO.
CDPO.
Yeah. Critical token aware.
Yeah.
Direct preference optimization.
Remind me, what's direct preference optimization?
Okay, so direct preference optimization,
Yeah.
it's a method for training LLMs
Mm-hmm.
where they essentially learn
Okay.
to prefer better outputs
Mm-hmm.
on their own
Okay.
instead of relying on like
Yeah.
external rewards or feedback from humans.
Mm-hmm.
The LLM compares its own outputs
Okay.
and learns to favor the ones that are more likely to be correct.
So it's like the LLM is becoming its own teacher.
Yeah.
Oh, that's fascinating.
And that's where CDPO comes in.
Okay.
It takes this like self-learning aspect
Mm-hmm.
and combines it with a knowledge of critical tokens.
Okay.
So by knowing which tokens are likely to lead the LLM astray, CDPO can guide it toward more accurate reasoning paths.
Okay. So help me visualize this. How does CDPO actually use this information
Okay.
to improve the LLM's training?
In simple terms,
Yeah.
CDPO penalizes the LLM
Okay.
for generating critical tokens.
Gotcha.
It's like saying, hey, watch out for these words. They tend to lead to trouble.
Yeah.
So by discouraging the LLM from using these problematic tokens,
Mm-hmm.
it's gently nudged toward better solutions.
It's like training wheels
It's a great analogy.
for an LLM's reasoning abilities.
And the results are pretty convincing.
Oh, cool.
The paper shows that CDPO outperforms other training methods
Awesome.
when it comes to solving these math problems.
Wow. So this is really demonstrating the
Yeah.
power of understanding these critical tokens.
Exactly. It's not just about brute force computation anymore,
Hmm.
but about recognizing these subtle but crucial elements
Uh-huh.
that influence the reasoning process.
So we're moving beyond.
It's a whole new way of thinking
Yeah.
about how we train and develop AI.
Simply making LLMs bigger and focusing on making them smarter by understanding how they reason at a much deeper level.
Exactly.
This deep dive is really highlighting
Yeah,
how important it is to understand the inner workings of these LLMs,
absolutely.
not just their overall capabilities.
And as we zoom in
Yeah.
and examine these critical tokens,
Yeah.
we're likely to uncover even deeper insights
Mhm.
into how these systems
Yeah.
learn and reason.
Yeah.
It's a fascinating area of research
Mhm.
with huge potential.
We've been focusing a lot
Oh,
on how these critical tokens affect problem solving in math.
right.
But is this something that could be applied to other areas
That's a great question.
where LLMs are used?
And it's one that researchers are actively exploring.
Okay.
If these tiny bits of text
Yeah.
can have such a big impact
Hmm.
on how LLMs solve math problems,
Yeah.
it stands to reason that they could also play a role
Uh-huh.
in other tasks like language processing, code generation,
Okay.
or even creative writing.
So the idea is that there might be critical tokens that influence an LLM's ability to write different styles of text, translate languages,
Yeah.
or even compose music.
The possibilities are really exciting.
Yeah.
Imagine if we could identify critical tokens
Yeah.
that make an LLM more likely to write compelling narratives,
Yeah.
translate text more accurately,
Right.
or compose music that evokes specific emotions.
Wow.
It could have huge implications for all sorts of fields.
Yeah, it's almost like we're talking about
It's a powerful concept.
a whole new level of understanding
Right.
and control
Yeah.
over how LLMs generate output.
But it's important to remember
Yeah.
that this research is still in its early stages.
Right?
There's a lot we don't know yet about how these critical tokens work across different domains.
So while the potential is huge, there's still a lot of ground to cover before we can fully unlock the power of this concept.
Absolutely. But the progress so far has been incredible. And I'm really excited to see where this research leads in the coming years.
This has been such a fascinating exploration of critical tokens. It feels like we're just beginning to scratch the surface of a whole new way of thinking about LLMs and their capabilities. But before we get too far ahead of ourselves, I think it's important to acknowledge that this research, like any scientific endeavor, has its limitations. What are some of the limitations we should keep in mind?
One thing that stands out is this research really focused on math problems. It's a great starting point, but it doesn't necessarily mean that these findings will apply directly to other tasks, like language processing, creative writing.
So the critical tokens that mess up the math might not be the same ones that are messing up the language stuff.
It's possible that, like, the nature of the task itself influences which tokens become critical. For example, in a math problem, one single misplaced like operator can totally change the outcome. But in writing, a slightly off word choice might have a much more subtle effect.
It seems like context is everything. Are there any other limitations?
They also acknowledge that the contrastive estimation technique, while clever, isn't perfect. It relies on training those separate positive and negative models, which can be really computationally expensive and time-consuming.
So trying to scale this approach up to like massive data sets and even more complex tasks could be a real challenge.
That's a valid concern. Plus, the accuracy of contrastive estimation really depends on the quality of the data used to train those models. If the data is biased or incomplete, it could lead to misidentified critical tokens.
Okay, so can we talk about some specific examples of these critical tokens?
Absolutely.
Really curious to see what these things look like.
One that we've already touched on is the word owed. Remember, in that debt-related word problem, simply switching it to paid made a huge difference.
It's like that word was acting as a mental roadblock for the LLM.
And it really highlights how even seemingly simple words can have a big impact depending on the context. It's not just about like mathematical symbols. It's about how those words relate to the overall logic of the problem.
So it's not as simple as just like creating a list of bad words.
And telling the LLM to avoid them.
Each word's meaning and function can change depending on the situation. And that's something we need to keep in mind as we develop these systems.
What about the mathematical operators?
They found that in some cases, swapping a division symbol with a multiplication symbol or vice versa completely changed the outcome of a problem.
Wow.
It seems like the LLM might be getting tripped up by the specific operation it's supposed to perform.
Interesting.
Even if it understands the rest of the problem perfectly.
So it almost suggests that LLMs might not be representing mathematical concepts.
That's a fascinating possibility. And it's one of the reasons why this research is so exciting. By studying these critical tokens, we might gain a deeper understanding of how these models process and represent information. Which could have huge implications
for how we design and train them.
This has been an incredible deep dive.
It has.
We've learned so much about these critical tokens. How they can influence an LLM's reasoning, how researchers are finding them, the potential they hold for like improving AI systems.
It feels like we're on the cusp of a major breakthrough in how we understand and interact with these powerful tools.
Where do you think this research might lead us in the future?
One area that really stands out to me is developing even more sophisticated methods for identifying and understanding these critical tokens. Contrastive estimation is a great starting point. But there's definitely room for improvement.
Yeah.
We need more efficient and reliable ways to zero in on these crucial bits of text.
What else?
Another exciting area is exploring how critical tokens might differ across languages and cultural contexts. It's possible that there are certain critical tokens that are specific to certain languages or ways of thinking.
Right.
And that's something we need to take into account as we develop AI systems that are used around the world.
So it's not just about making LLMs more accurate and powerful, but making sure that they're aligned with the diverse ways that humans communicate and understand the world.
This research has the potential to revolutionize how we think about AI. But it's important to remember that it comes with a responsibility to use this knowledge thoughtfully and ethically.
Well said.
Yeah.
Well, this has been an incredible deep dive.
It has.
Into the world of critical tokens. I hope you learned a lot about these AI systems and how important it is to understand how they work.
Absolutely.
At a very deep level.
Thank you for joining us.
Yeah. That's it for this episode of The Deep Dive. We'll be back soon with another intriguing paper.
Okay.
Ready to break it down and uncover its hidden insights.
Sound good.
Until then, keep exploring.
Yeah.
Keep questioning. Keep pushing the boundaries of knowledge.
Absolutely.